Hello, welcome to the last section of Chapter 2, Section 2.3b for stats. Let's talk about our final types of graphs. So we've been doing a lot of data and organizing it and presenting it. So the next way we've got is a pie chart. Everybody's familiar with a pie graph. It's a circle that's divided into sections or wedges or sectors, we call them in geometry, according to the proportion or percentage of frequencies in each category. It's awfully wordy when you know how to do it. We might have to do a little math review. You'll probably need a calculator to do some dividing and multiplication. So if we are going to set up a pie graph for the practice number 5, the reasons we travel, first thing you're going to want to do is find your relative frequency for each category. Everybody knows that relative, right, is frequency over n. Keep it as a proportion, or don't even change it, just leave it in your calculator however you got it, because step 2 then is to calculate your degrees. So if you take your degrees or your relative frequency and multiply by 360, you are going to end up with your degrees. So relative frequency as a proportion, as a decimal, times 360. Why 360, you ask? Everybody knows, right? That's how many degrees are in our full circle. So we're basically taking and figuring out what proportion of that circle is dedicated to that particular category. And then from there, and I'm not going to be this picky, but technically we should draw in our sectors using a protractor. I'm going to ask you to eyeball it. I think everybody knows that 90 degrees or right angle is about a quarter of a circle. So use that to judge. We can go from there. I'm not going to take out my protractor and diagnose if you're on or not. Please label each sector with your class and percentage. I don't think I need degrees, just percentage is helpful. So again, when I do relative frequency, I do not change it into a percentage. I leave it as whatever that never-ending irrational decimal is, if it is, multiply it by 360, and then I can put my percentage on there with a quick round. So let's do some quick math here. Use the data to determine the degrees and percentages. So if my frequencies are all listed, the reasons that we travel, personal business, visiting friends, blah, 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 we probably need to know what our n is equal to. So if you do a quick add there, I believe it's 800. I really need to do this. I'm going to take that out. I'm going to call this category relative frequency. And then I'm going to call this category degrees. Every time I make a pie graph, I am going to jot those two things down. It's a lot more helpful than the way that I initially had it. So relative frequency is our frequency divided by n. So if you've got a calculator, you're going to do a 146 divided by 800. Please calculate that really quickly. Verify that my numbers are correct. I've got that as a 0.1825. It's not irrational. It stopped there. I'm just going to leave it like that. And then I'm going to take that value, I'm going to multiply by 360 to find out how many degrees of the circle that is then. So that's going to end up being 65.7 degrees. If you want to put down that this is 18.25%, feel free. I think most of us are pretty good at taking our relative frequency, our proportion, turning it into a percent. So 130 people visit friends or relatives. If I take that and figure out my relative frequency, I believe, I'm having a hard time. Let me calculate that really quick. 130 out of 800 is 0.1625. If you were here, I'd be asking you to calculate for me. Take that value, multiply it by 360. Tell me if I'm wrong, but I believe it's a 58.5. Work-related travelers, 225 out of that 800. So that's going to be something like 0.28125. Again, I'm not going to write down all these crazy numbers, I'll probably just go to my calculator, multiply that by 360, and know that it's going to be 101.25 degrees. And last but not least, 299 people travel for leisure. I'm with them. That's going to be 0.37375. And when I multiply that by 360, I'm going to end up with a grand total of 134.55 degrees. What should all of this add up to? If I add up all of my relative frequency, that should add up to what? 1 whole, right? If I add up all my degrees, what should that add up to? 1 whole, if I'm talking about a circle, is 360 degrees. Why might the total percentage not add up to 100%? We all know the classic issue of rounding. That's why I did not round anything along the way, because I didn't want to lose any of that value along the way. When I write stuff down, I might, however, round. So now remember, technically I'm supposed to draw in my sectors using a protractor. That seems like a lot. I'm going to start right here with this 101, because that's only 10-ish degrees above 90. So if I go straight down, try to find the middle, 90 degrees is a right angle, so it's just a little bit past. This would be work, and I'm going to say that's 28.13%. I'm going to pretty much stick to hundredths for my percentages. And then I can go from there. My 65.7 degrees for personal business. 90 degrees would be about like this, so 65 is going to be something like this. That is personal. 18.25, sorry. That was degrees I was doing. 18.25 degree or percent. Check that one off. 58.5 is going to be a little bit less than this one, a little bit more than halfway, so that's probably going to be something like that maybe. That's going to be visiting, and that's at a 16.25%. That leaves me roughly 134 degrees. That's a pretty large sector for leisure, which is 37.35%. If you're in the general ballpark, 37% is just over a third. That looks about right. It's not too far off. Again, if I were being super technical, I would make I would use my protractor. So percentages, round to the hundredths place. Pie graph. We look at them all the time. We don't often construct them. I hope that you knew how to figure out degrees. If not, I hope you know how to figure out degrees using your relative frequency. Next up are dot plots. I actually had a stat student from last year who texted me and said, I made a dot plot at work, and she was so impressed. And I said, that's stats in the real world, you know. So dot plot, each data value is plotted as a point or a dot. I actually typically use an X above a horizontal number line. This is a two-dimensional representation. We just use a number line. This preserves your raw data. You don't use frequencies, you don't use relative frequencies, you don't use proportions, you use your raw data. So we've got strict, we just know what each piece of data is and how often it shows up. So if I were to ask you to make a dot plot about these lightning strikes in Pennsylvania, first thing you would need to do is find your highest and lowest values, draw a number line, and get that scale on there. You can start with your lowest and end with your highest. You don't have to make it some kind of crazy long number line. Second thing, place a dot, or like I said, I'll use an X above each value. And then it's going to ask you to analyze the shape or tell me something. So comment on the shape, comment on the data, and use the context of the problem. Tell me what it's about. The numbers of lightning strikes. So use that in your comment. So for a township in Pennsylvania, the numbers of lightning strikes for the last 14 years are shown. Construct a dot plot for the data. Just out of curiosity, do you already know what your N is going to be? 14, right? That's the number per year. Therefore, you are going to have 14 dots or 14 X's above your data. Our smallest value is a 3, it looks like to me. Our largest is an 18. So when I make a number line, I'm going to start with 3, I'm going to end with 18, and I'm going to make everything in between. Set that up any way you want to. So 10 would probably be about right here. Ten. 18. Whoops. So while you go ahead and get all your dots on there, please get that done so you can compare. I am going to sneak out my pre-made dot plot. Notice they went from 0 to 20. I'm not going to do that. I'm going to start at one end. And don't forget, it is a number line, so stick your arrows on the end. So they use dots. Like I said, I use X's. I just think it's, I don't know why. I just learned it that way. And if we were going to comment on this, I'd say there were mostly between 7 and 10 lightning strikes in Pennsylvania over the last 14 years. It went as low as 3 lightning strikes in a year and as high as 18. I commented it in context, so in terms of lightning strikes. Sometimes that's the hardest part. Everybody can make a dot plot. All right, next up, stem and leaves. I'm wondering if you remember making stem and leaves. Some people are like, oh, I know how to do this, and others have said they never have done this before. So a stem and leaf plot is a graph that uses a stem and a leaf. The stem is the left-hand digits, so the larger, the tenths, hundredths, whatever it might be. The leaf is the ones place, typically. It will be for this data. We could make the stems and leaves, we could go into the hundreds or thousands if we needed to. This shows the shape of the data, preserves the detail. We also use raw data on this. So if we were to make a stem and leaf plot for outpatient cardiograms performed each day for 20 days, we would start off by arranging the data in order. Some people try to do a shortcut and not arrange the data in order, but then you get messed up, you miss things. Be careful, because everything in a stem and leaf has to do with order, both in the stems and the leaves. Then you're going to separate the data. So if I've got something in the 10s, the 20s, the 30s, the 40s, the 50s, I need that all grouped together. And then I'm going to put it on my stem and leaf display. I use the leading digit as the stem and the trailing digit as the leaf. Everything is in order, including the leaves. So if I make I'm going to put up here, separate the data according to the first digit. In this case, it's the tens place. So if I go to make a stem and leaf plot, my lowest value is what, 2? It's weird that I wrote it as 0, 2, but I just wanted to remember there is a tens place for the number 2. It's a 0. We have 0 tens and 2 ones. My highest piece of data, what would that be, like a 57 it looks like? So my range is from 2 to 57. So my leading digits are from 0 to 5, right? All of my tens places. So 0s, 1s, 2s, 3s, 4s, and I better scooch down for a 5. I wrote too big, I think. Here we go, I can fix that. Don't you wish you could do that? All right. So now I'm going to go through. Again, if you write everything in order, it's really helpful. If you don't, I've got the only thing I've got with a 0 out in front is a 2. So all I have to do is put 2. It's showing me I have one piece of data that is 2 or 0, 2. Then I'm going to go to my tens. Anything with a 10 or a 1 is a lead digit. I've got a 13, a 14. Is that it? So that means I've got to have a 3 and a 4, and they have to be in order. If it was a 4 and a 3, I would write it as 3 and 4. Give yourself a little space in between them. It's not a 34. Then I'm going to go to my 20s place. I've got 20, 20, 20. Looks like just those 3. So put that ones place in order. If I'm going to do that, I've got a 0, 3, 5. Notice how I'm kind of lining them up as I go down my leaf section. It's all about organizing the data. 3, so 30 anything. Lots of 30s. If I have a repeat, do I want to write it twice? If I don't write it twice, I don't know that I have 2 of them. Remember, every single one of these leaves is standing for one piece of data. So for my 30s, I believe I'm going to have a 1. And then how many 2s do I have? So there's that one. 1, 2, 3, 4 2s. And then I've got a 3 and a 6. For my 40 anythings, I've got 40, 40, 40, 40. 4 of them. So put them in order. I've got a 3, 4, 4, 5. Everybody's getting the idea, right? And then for my 50s, all I've got left is a 51 and a 52 and a 57. So 1, 2, 7. If I count up all of my leaves, it should be the same as my number of pieces of data. It should be 20. So now we can kind of see a shape. Notice it's biggest in the middle. We might even say it's a bell shape or a bell curve. There's a little question over here on the side. If you don't have a leaf, don't put in a 0. Because notice right here, I've got a 0, but that stands for 20. If I didn't have anything in the tens column, if I put a 0 in there, I'd think I had 10. If I put nothing, I know that I have nothing with the lead digit 1. So you just leave it blank if you don't have anything, even if it's in the middle of your stem and leaf plot. All right, and I just said that. I think that it probably looks like a bell curve. It looks pretty symmetric. All right. So last but not least, there are back-to-back stem and leaf plots. Back-to-back is the same idea, except it's 2 stem and leaf plots that compare 2 different data sets. The stem is in the middle. The leaves go out to the left and the right. And each set of leaves are arranged in numerical order from the stem, from the center. So on the left-hand side of that stem and leaf plot, you actually count backwards because you're working out from the stem in both directions. So if we are going to talk about the number of stories in tall buildings, I've got Atlanta and Philadelphia. I guess the first thing I need to know is what about my stem? So my stem and leaf plot is going to look something like this. I'll put Atlanta over here, and I'll put Philadelphia over here, and my stem is going to go in the middle. I just put the first set of data first. So what do we have as far as stems? My lowest data, oh gosh, I see 30s, I see 20s, 26 my lowest piece of data. between both of them, all the way up to, I see a 61. Anything higher than a 61. So 26 to 61. So then that makes me think I need to have stems and leaves up to, oh, look at this, I missed a 70. So 26 up to 70. So my stems are going to be 2s through 7s, just my first digit. So 2, 3, 4, 5, 6, and 7. Let's just talk about Atlanta for a minute because I think you'll be good with Philadelphia because it's exactly the same as the one we just did. Atlanta, though, it's all about the order. So if I look at anything in the 20s in Atlanta, 20s, 20s, 20s. I've got 2 pieces of 20, so I'm going to have a 6 and an 8. If I'm counting out from the stem, I've got to have a 6 and an 8. In Philadelphia, if I'm counting out from the stem, looks like I just have that one. I count out in this direction, and I would go this way. Do I need to do more of it? Is everybody okay with that one? I think I've actually got it set up here. So if you do want to do it and check, did I miss a 9, a 29 in Atlanta? I sure did. Look at that. I'm glad I did that. I missed that 29 right there. So I should have a 9. Notice how this Atlanta, remember, it's counting basically backwards because it's counting out from our stems, out from our stems. Notice how in Philadelphia I don't have any leaves for the 7 because I don't have any digits, any values that are in the 70s. So zeros represent a piece of raw data. All right, so let's talk about misleading graphs. We've talked about misleading stats, and I bolt graphs in because they're the easiest to see. Graphs enable readers to analyze and interpret data more easily. Raw data is just a bunch of numbers a lot of time. That's why we put them in graphs. However, if you've got inappropriately drawn graphs, you can misrepresent your data, and people may draw false conclusions. Sometimes they want you to, sometimes it's just purely an accident. The scale of the vertical y-axis should not be truncated unless the reader is made aware of this. That's the easiest place to mislead somebody is on the y-axis. So if you just take a look at these two graphs, if we change the scale on the vertical axis, this one starts down here. I can't even tell what that starts at. Maybe you can see it, but I can tell that this goes from 0 to 100. I'm not sure what that, I see it goes up to 100. Is that like 85 or something, up to 100? So that's a real problem. This guy is a big old, notice how it makes the bars look like there's so much difference between them, when in reality, these 3 values are very close. So all they're doing is magnifying that difference. On this one, again, vertical axis, this is starting at 20 and going up to 24. This is legit. So the reason that we're not allowed to do that, or that we have to put the little squiggle in there, is because we have to show we're marking these off on the vertical axis by equal widths, just like our class widths have to be equal. But if I don't notate that, that is going up by 21, and then each one of these is 1 unit. So it's misleading you to see it. Notice how on the properly labeled one, it's a relatively flat, maybe a slightly increasing time series graph. I see more of an increase in the other one because of the way that labels, the label on the y-axis. If we go to 1 to 2 dimensions, to me, because we are looking at area, it's the same data. All we're really looking at is the difference between these 2 bars. But when we look at the round one, because we see area, it looks so much larger, even though it is a relatively large difference. And this one does not have a vertical scale. I don't even know what the y-axis is. Right? That's a big question mark. I have northeast, south, and west, and crime rates and other things, but I don't know what that is. Is that percentages? Is that raw data? I can't really compare things. I don't know how great of a difference this is without having some sort of label. So just watch out for those misleading graphs, misleading stats. That is the end of section 2.3b and the end of chapter 2.